Sorry about that, guys. Technician A says an analog scope can store the waveform for viewing later. Wrong. Technician B says the trigger level has to be set on most scopes to be able to view a changing waveform. Technician B is right. Do you guys remember when I showed you the scopes the first day that you were here? You got two settings on the scope. You basically are going to be looking at each axis of that scope. The voltage is the vertical one, and the time is the horizontal one. If you don't have that set right, if you're looking at something that's happening real fast, you got to go to make it read faster. And each box is what you're looking at. An oscilloscope display is called what? What's it called? Number 2. That's called a graticule. Remember that word. That's a good Scrabble word if you got a lot of letters.
What was the answer number 1?
The answer number 1 is B. Number 3, a signal showing the voltage of a battery displayed on a digital storage oscilloscope has been discussed. Technician A says the display will show one horizontal line above the 0 line. Technician B says the display will show a line sloping upward from 0 to the battery voltage level. You know what he's saying? All right. Basically, that is a very peculiar question. I mean, it's strangely worded. Digital storage oscilloscope. If you actually see what he that question, if I was reading that question and it was on an ASC test, I would have no earthly idea how to answer it. I obviously wouldn't. Basically, what they should have said, if you actually connect it to your battery, and you've already got it connected to your battery, this is how what they're talking about here. And you got 0, and you got somewhere up here. Let's say you got 5, you got 10, you got 15, right? All right. If you hook up, if you got a battery hooked up, you're going to see this. All right. That's basically what you're going to see because it's actually drawing you a picture of what the voltage is doing over time. And so that's what that means. You're just going to see a horizontal line at about the 12 volt range on that. And so basically the long and the short of it is that one there is going to be an A. Setting the time base to 50 milliseconds per division, and this is your divisions on the scope right here. With PDs, right here you usually have those, and you got divisions going up too. See that? And so, but anyway, this would be 5 volts per division. See 5, 10, 15, and whatever your 50 milliseconds would be. Every time it travels from this line to that line, it takes 50 milliseconds to do it. So the overall screen is going to be, if you got 5 over here, you're going to be 5, 10, 15, 20 milliseconds going across the whole screen. Understand that because it's important that you do. Number 4 is D. A throttle position sensor waveform is going to be observed should the voltage for division be set to see the entire waveform from 0 to 5 volts. Should they be set for what? Remember what I said? If you set it so that it's going to go off the top of the screen, you're not going to get the whole waveform. If you set it to where the voltage is too high and you're just reading between 0 and 5, you're going to be just using this part of your screen and the resolution is not going to be very good. So I'm going to be basically setting that so that my total screen resolution is going to be 5 volts. Now they're actually talking about, the scopes that I'm using, like that one over there and the one out here, typically have 5 blocks that way and 5 blocks this way, each one being a division. See that? And so basically, if you go by that, I mean, they may have 10 on the scope that they're talking about here. So that's kind of got to screw up anyway. One way or another, as long as you understand that, that's basically what you're going to be looking at. On number 5, it's going to be B. That's 1 volt per division. See this? 1, 2, 3, 4, 5. Nope. They got a 5 block one. That's what it is. 2 technicians are discussing the DC coupling setting on a digital storage oscilloscope. Technician A says the position allows both the DC and AC signals of the waveform to be displayed. Technician B says this setting allows just the DC part of the waveform to be displayed. Which technician is correct? That's A. That guy is A. Number 7, voltage signals or waveforms that don't go below 0 are called what? Somebody should know that.
A.
Huh? That do not go below 0 are called, I would say that's a DC signal. Wouldn't you say that? If they don't go below 0?
That's what I was saying.
Said A, DC signal.
But now what they're saying, See, AC signals do go below 0, but their stupid answer key is basically saying that. No, it says C, but that's not right either, because AC signals go below 0, right? Well, I actually call them, I guess what they're wanting to call them is pulse trains, which I guess that would probably be what you'll see in your book, pulse trains. Put C on there. Cycles per second are expressed in what?
Hertz.
Yeah, we talked about that earlier. Good call. Oscilloscopes use what kind of lead connector?
Banana plug.
No, actually, they use the D is a BNC connector. You know these that I got to stick in and turn to lock. That's what that kind of connector they're talking about. You stick it in, turn it, and lock it.
What was 8?
Oh, 8 was 8. A digital meter that can show waveforms is what?
DSO.
That's a C. That's a graphing multimeter, a GMM. All right. Number 11. What type of oscilloscope displays all voltages without taking samples? That's an analog meter. Technician A says analog scopes use an LCD display. Technician B says digital scope may use CRT display, cathode ray tube. That's going to be B. I mean, either one of them, there's all kinds of scopes out there. A digital storage oscilloscope is being set to measure a waveform where a certain voltage is detected. The minimum threshold is called... That's a trigger. You remember how on that scope out there, when I would put that trigger at a certain place and it won't read anything unless the voltage crosses that threshold? That's pretty handy if you're driving down the road and you got a scope hooked to a particular lead. Let's say that let's say that you're hooked to a particular. You say, I suspect that I'm losing my signal on this particular wire, right? And so what you're going to do, if you're saying, let's say you got your scope set up, and your scope is actually reading. It's on the 20-volt scale, and I'm just drawing this real simple right here. And you know that 12 volts would be about right here. And you know that if that voltage ever drops below 5 volts, you found your problem, right? If it ever drops below 5 volts, you found your problem. So what you're going to do is you're going to set your trigger right here. You can do that. You right click, you set your trigger where you want the threshold to be. All right. That scope is going to be totally blank as long as it doesn't see voltage that drops below 5 volts. Got it? Or let's say that you think the voltage is jumping up or something like that. So if you set your trigger, as soon as that happens, let's say that you're watching your scope and your car goes boom, boom, and you see that pattern, you'll know it dropped below 5 volts. That's why you set that trigger there. There's another reason too. You notice how when you hook up the scope, the pattern walks? When you set the trigger, if you can set the trigger on a place where it's the highest point, it will stop.
Got a Jeep. Just like that one right there. Crankshaft off, back and forth.
Oh, you mean the, yeah. Oh, well, what do you think might cause that?
Worn out thrust washers.
Huh?
Worn out thrust washers.
When you saying the crank goes actually front and back?
Forward and back. And it just,
yeah, you got, well, yeah, and also, I'll tell you what you better do.
Have you ever seen that before?
Yeah, I mean, I tell you what
found that on the Jeep the other day.
I tell you what you better do on that thing too is you better put a torque converter in it.
Right, I know. The lady on the she's.
Yeah, I see what you're saying. She's wacky.
Yeah, but yeah, the sensor point here at the crank, the reluctor wheel on the crank, and it moves in and out.
Yeah.
And it don't do it until it gets probably about just a little bit hot.
Yeah.
It'll idle perfect. Mike told me he knew what it was, and he said find out what it was. I drove it.
He sent you hunting it, didn't he? Yeah.
I felt it.
Yeah.
All right. I didn't never put nothing about that. And then I got down there and I pulled the crank pulley.
And it clunk, 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 clunk.
Yeah.
Yep. You got it.
It was ridiculous. I never seen nothing like that before.
Yeah. You could probably put a spring-loaded button on the front of it and hold it back. It'd be okay. Okay. Now, some of your camshafts had that. And, they had a spring-loaded button on the pushing on the camshaft all that. All right, let me look at what number am I on? 13. A digital storage oscilloscope is set to begin displaying a waveform when a certain voltage. That's trigger. That's the trigger. Okay. Number 14. A typical DSO display screen is arranged in what kind of grid?
I don't know.
8 by 8.
Yeah, this one here, 8 by 10. That's the size of the grid, you know what I'm saying?
Dang.
All right, Technician A says voltage is usually indicated on the horizontal display axis. Technician B says the time is usually indicated on the horizontal display axis, and that is, those guys are right. Both those guys are right. Wait a minute. Excuse me. I'm wrong. Horizontal display. I was thinking vertical when I said horizontal, and it's crazy how your brain does that. But Technician A is wrong because voltage is not indicated on the horizontal display axis. That's your time. So B is the right answer to that one. I messed up on that. Sorry about that. The time-based setting reduces the number of samples per second. What time? What time-based setting? Number of samples per second. B, if you increase it.
Oh, increasing.
Yeah, if you increase it. You increase the time-based setting, and you're going to reduce the number of samples per second.
You know what Ryan did?
What?
He wouldn't trade it to Civic for a car that's knocking.
For what?
A car that's knocking.
Civic any good?
You talking about Ryan Mills?
Yeah. It wouldn't have.
I don't understand how some of these guys think. Okay.
I don't either. I think I got to replace time machine.
Okay. That's the time setting of 1 millisecond per division will show a total time of what on the scope display?
10 milliseconds.
1 millisecond per division. 10 milliseconds basically. But see, that's if you got that's what you got 10. If it's 8 going up and 10 going back and forth. Ours is set up that one and the other one I got out there and set up that way. Which of the following is a correct voltage division setting for testing a throttle position sensor?
5 volts.
Actually 1 volt because it's got that number of divisions.
Most answer than 16.
Remember what I said though? Yeah, your divisions is per division. When you set that voltage, it's how many volts per division it is. I mean, that's how that scope is set up. If you set it at, you're thinking, well, I'm thinking 5 volts, so I'm going to go set it at 5 volts. Well, you do that, you got 25 volts total because it's 5 per. You got that? Okay. Now we're almost through here, and then we can hit the shop. And I appreciate all you guys being here today. All right. Let me see. Which of the following is the correct? Oh, we got that one already. That's 18. Which of the following is measured as a percentage?
Duty cycle.
Duty cycle.
Duty cycle. And what do we use duty cycle for?
To know when you got to change injectors when you got too much glue.
The injectors operate on a duty cycle, and so do a lot of other things on these cars. Which of these terms is a measure of the actual on time based on milliseconds? Pulse width. Pulse width. Yep. These duty cycle solenoids, like you used to have in the old GM carburetors, would go up and down 10 times a second, but they could vary in their own time from 9/10 of a second to 1/10 of a second.